Thanks for joining. Today we're going to talk about the profit milling upgrade that was made to closed cavities. So we optimized the profit milling toolpath to minimize the deceleration as well as improve the chip evacuation and coolant access. Now, once we made the changes to the algorithm for profit milling, we had our engineer that's inside the Mazak US Application Technology Center in Kentucky validate these improvements. Overall, we found a productivity increase of 5 to 10% based on what kind of geometry you are cutting. So on this slide, we see our new toolpath on the top with the spiral as compared to the old profit milling toolpath without a spiral. And as I mentioned on the previous slide, the productivity increases of 5 to 10% depended on the feature length. So we did a variety, a 10, a 15, and a 20-inch feature length test cut, and you can see the reduction in cycle times for each cut. So even in a worst case scenario where you have a donut shaped cut, the initial spiral toolpath with the new profit milling resulted in an increase in productivity. During the test, we discovered that the fastest cycle time was achieved with a clearing width of 0.5 to 0.75 of the tool radius. So on this slide, we summarize some of our findings from our test cuts. If you were to open up the operation page and want to use the profit milling in the new ESPRIT TNG, you'll notice that there are no new settings, and this is the coolest thing to me. The optimization is done entirely by the toolpath using your existing user input, so there's no new settings to fiddle with to try to get the optimal toolpath. Let's look at a quick comparison of the old profit milling versus the new profit milling. So in this particular file, I have a toolpath that's already been generated, a pocketing toolpath using the old profit milling. So I created this in a previous version of ESPRIT TNG. What I'd like to do is I would like to take this operation, we'll just do a simple copy and paste onto the new pocket, then we can do a side-by-side comparison and we can see how the new improved profit milling compares to the old profit milling. Biggest difference you'll see, most apparent difference, will be that maximum spiral out at the beginning. And of course, if you wanted to, we can run the simulation. To get an idea of our tool motion pattern. Maximum spiral out until I can't spiral out anymore. Thank you for joining me today. I hope that you learned something new and something that you can apply to your everyday programming. Have a nice day.